Today everyone, my name is Xiao Ying from Chemical Engineering. Today, we are going to present our Engineer in Society project entitled Flix-Bosch Chemical Explosion. In this era of Industrial Evolution 2.0, we all work in steadfast paces to develop the industrial technology. However, we should always look back and investigate the incidents that happened in the past, taking them as lessons learned. As such, Flix-Bosch Chemical Explosion is studied with three main objectives. First, the technical reason that caused the incident to happen, or so-called the root cause, will be studied. Second point, tactical reasoning by evaluating the action of the engineers or management. And lastly, several recommendations will be proposed to prevent the similar failures from happening in the future, according to the Code of Ethics. Flix-Bosch Chemical Explosion is well known as a massive explosion by a company called Nipro United Kingdom Limited. Looking into the manufacturing process, it aimed to produce 70,000 tons of caprolactam per year. There were two different processes in this company, whereby the oxidation of cyclohexane was an additional plant to achieve the production target. However, this plant posed hazardous potential in terms of operation and inappropriate modification, which will be explained in details later. The explosion occurred on the 1st of June in 1974, which 28 on-site workers were killed and 36 suffered from several injuries. Outside the plant, 53 villages were recorded as casualties, whereby nearly 2,000 buildings were damaged. That's all from me. I will pass the rest of part to my teammate.
Good day, my name is Ooi Wei Ching. Now I'm going to explain the incident timeline of this explosion. This figure shows the arrangement of reactors in the oxidation plant, and our focus today is the fifth reactor. On 27 March 1974, a 6-feet long vertical crack was found on the fifth reactor and some cyclohexane was leaking. On the next day, inspection was carried out by the Dutch State Mines, in short DSM. They found that the crack was due to the nitrate stress corrosion on the mild steel cladding. So, they decided to replace the fifth reactor with a 20-inch diameter bypass. It was connected to the 28-inch expansion fan of the 4th and 6th reactor. Everything went well until 29th of May. A leak was discovered through the side glass of the bypass. Repairing and restarting process was conducted several times as more leakage were found. Due to lack of necessary tools, immediate repairing action was also unable to perform. Later, in 1st of June, the plant was restarted by warming up the reactor at 9:30 a.m. However, the pressure of the reactor rose up to 0.89 megapascal. Besides, due to insufficient nitrogen stock for purging, hot cyclohexane was recycled under pressure with no air admission. Later, in 4:53 p.m., the bypass was deformed to V-shape due to bending stress from the pressure, and it was broken with two expansion fans. This caused large amount of cyclohexane released from the 4th and 6th reactor and formed massive vapor cloud explosion that destroyed the nearby units within 35 seconds.
Hi everyone, my name is Woh Sook Khee. So I'm going to present on the technical reasons for failures in Flix-Bosch chemical plant. As stated before, a temporary dogleg-shaped pipe was used to replace 5th reactor and installed between 4th and 6th reactor. This is because the leaking problem of 5th reactor was very serious, as there was a crack over 18.3 cm long in the mild steel. So the design of the dogleg-shaped pipe was reproduced under terms of Crown Copyright Policy Guidance, which issued by Her Majesty's Stationery Office, and the exact source was from the Secretary of State of Employment, 1975. So there are actually three possible reasons on the chemical explosion, which are 20-inch pipe hypothesis, followed by 8-inch pipe hypothesis, and the last one will be water theory. So at the end of the public inquiry that conducted right after the chemical explosion, the most possible reason will be 20-inch pipe hypothesis. So now let me explain more on the 20-inch pipe hypothesis. So this hypothesis indicated that the explosion was caused by the unsatisfactory design features of the 20-inch dogleg-shaped pipe, and the broken of the pipe was caused by unreasonable conditions of temperature and pressure. However, the inquiry concluded that this hypothesis might be replaced in the future if any greater probability can be found. This is because the 20-inch dogleg-shaped pipe was operating normally for 2 months before the chemical explosion. Also, the value of the pressure that causing the explosion was unlikely achievable by reactors. As we know, the normal operating pressure for the bypass is about 8 bar, and there was a practice before the startup that allowed the pressure to build up until 9 bar. Also, there was a safety valve that said to be discharged at 11 bar. As predicted, of course, the bellows were distorted at the pressure of 11 bar. However, the distortion level of the bellows did not possibly lead to a serious rupture that could cause a chemical explosion until the pressure crossed over 14.5 bar, which is a value of pressure that would not achievable by reactors. Therefore, the most possible explanation for this chemical explosion was there was an unusual conditions of temperature and pressure on that day of the incident.
Assalamualaikum and a very good day. My name is Zharfan bin Hisham and I will continue with the ethical failure from the Flixboro incident. So basically I have summarized the ethical failure into 2 major points. So the first major point is defective human resource. So from the first major points, there are 2 issues rises, where the first one would be no qualified replacement for the previous maintenance engineer. So basically the maintenance engineer left the company and then the management decided to replace the engineer with the mechanical and mechanics experience. They replace the engineer with a technician that have lesser qualifications and also lesser experience in the field. So this portrays the incompetent management in the company and also portrays an unethical attributes. So the second issue is the unclear role of safety engineer. So basically this is because the safety measurement taken during the installation of the bypass is very uncertain according to the report by the Commission of Inquiry. So the second major point of ethical failure is the economic and commercial pressure. So since the demand of the product is high, so there are 2 issues rises as the result of the factor. So the first issue is unprofessional work ethics. So the technicians basically did not conduct a sufficient pressure and strength test, and this is also reported by the Commission of Inquiry, where they stated that there is no proper calculation were made for the newly installed pipe between the reactors. So that brings me to the next point, which is the lack of communication between technician and the management, because the management supposedly to monitor the technician work progress in terms of the calculation made, so as to ensure the safetiness of the newly installed pipe. So the second issues as a result of the commercial pressure is the rushing restart of the production line. So since the initial leakage occurred, there is actually no real inspection of the real cause of leakage. So they just basically add a modified pipeline system for the current problem and avoid the real cause of leakage. So they supposedly need to inspect the initial cause of leakage in order to ensure that the problem will not occur in the future.
Assalamualaikum and a good day. My name is Muhamad Alif, and today I will take over the recommendation part. So the highlight things regarding the recommendation is about the arrangement of process and non-process building for the plant layout. So let's have a review again regarding the incidents. In fact, there are 28 workers who lost their life and 36 suffered severe injuries. Fortunately, this incident was occurred during the weekend, and the main office block is not occupied by most of the staff. And then the highlight thing is here is the buildings of the process area and non-process area are placed side by side. So from this figure, the section 25A building where the incident occurred placed just beside the main office block. This is not a good approach actually, because the process buildings has many possibilities of risks and hazards. So the recommendation part here is the number of fatalities can be reduced if the main office block was placed in a specific distance with the process area. So the next recommendation is the recommendation related to the code of ethics of engineer, and then it is divided into two parts. First of all, I will explain regarding the regulatory requirement first. So in this incident, the mistake here is the engineer not perform the full assessment of the potential consequences when there is a modification in the plant. So in this case, when the installation of the bypass, there was no senior engineer in duty, and also the general chemical engineer personnel were incapable to recognize the existence of simple engineering problem. And also, the engineer not produce the drawing when they are done the modification. The drawing is very important as the reference for them and to other workers. As a result, when there is no drawing related to the proposed modification, the potential hazard is being hard to evaluate due to the shortage of the information. So the recommendation here is the engineer must follow these two regulatory requirements, which are the engineer should notify the relevant authorities change in design or withdrawal of services, and also the engineer should ensure that HSE measures are implemented as per drawings and specification.
In conclusion, the technical reason includes the 20-inch pipe hypothesis and using scaffolding as supporting structure. Next, hiring an unqualified maintenance engineer, unclear role of safety engineer, and lastly, unprofessional work ethics are attributed to ethical reasons. And lastly, to prevent repeating these incidents, a proper plant layout with a safety distance from the process plant is needed, and we must always follow the code of ethics at work. That's all from us. Thank you.